Okay, so that's that. We're going to back out of second grade and go into third grade. Now, as usual, we already have, as you can see, 4% of this done. That is because Khan Academy always works in some review from the previous year, and they don't require you to do it again. If it's a topic that you've already mastered, you get to keep it mastered. So I did not sneak in and do 4% of this when you weren't looking. So we're going to go ahead, and I think I don't need a calculator or my whiteboard to do one-digit multiplication. I really, really hope that I can do one-digit multiplication in my head without the need of anything like that. Okay, so first thing, this will be very easy. Multiply by 0 or 1. This is a pair of rules that are absolutely fundamental to multiplication and to everything that we learn going forward. And it seems really weird that we're looking at it, but it's very good to remember that when you multiply a number by 0, you get 0. And when you multiply a number by 1, you get 1. This is the very beginning of multiplication as scaling, right? If you scale something down to 0%, then it's not a thing, it's gone. If you scale something to 100%, then it's exactly the same size. That's what that means. Okay, so we're gonna jump through this really, really super duper fast. I'll zoom in a bit, but let's just get this over with. 6, 0, 9, 0, 2, not 22. 1, I'm sorry, 0, 4, 0, 7. It's so, once you start realizing that 0, it's just the perfect number when you're dealing with multiplication, because once you multiply by 0, everything goes away. So, there we go. In a lot of problems on down the line, you're going to want to try to find a way to make 0 in a way that will give you some benefit, some advantage. We did it with addition and subtraction, right? By zeroing out one of the digits to make addition and subtraction easier. Anyway, that was easy enough. Multiply by 0 or 1, and again, a moderate step up. Multiply by 2 or 4. Now, before I start talking more about multiplication, and I'll just go ahead and start going through these. 6 times 2 is 12. In kindergarten and first grade, I really recommended board games as a tool for teaching students addition and subtraction and sort of the order of things and counting and all of that. 2 times 5 is 10. I like the visual aids here. 9 times 2, I like how this is visualized. Take a look at this. This is visualized as 9 jumps, each of which is 2 lengths long, however much those lengths are. We could also have done it the other way, right? We could have just gone one big jump out to 9 and a second big jump up to 18. Both of those would be correct. And we're going to talk a little bit more about what that means in a bit. 2 times 8 is 16. 2 times 6 is 12. But when it comes to multiplication, you can't beat tabletop games like Dungeons and Dragons, which I always very, very strongly recommend as a help with both, in general, it's a wonderful game, but also it does test a lot of your mathematical capabilities, and there is a fair amount of multiplication early on in the leveling curve. There are a lot of things that you can do to double your damage, double your, your proficiency bonus, whatever. All right, now we're just going to multiply by 4. 5 times 4 is 20. My point being, while it's fine to have students sit down at a computer and do math problems, that's fine, but this is boring. You're not not excited by the fact that I'm typing in correct answers to multiplication problems. I do really like these visuals though. It's not exciting. What is exciting is to take multiplication and make it a game, and there are lots and lots of games out there that do that. Even Monopoly, you can do some multiplication practice, although that's just the worst game. All right, multiply by 2 and 4. 1 times 2 is 2. 4 times 10 is 40. When I was a kid, we used to do contests. Little bit of a story. I went to a private school for my first 3 years, kindergarten through 3rd grade. So the first 4 years of school, I went to like a fancy, swanky private school. And when I came to public school for the first time, we had my teacher had a contest, I guess, where we were doing times table stuff. And because I had just memorized the times tables, I was able to spit out answers really fast, and I won the game before anyone else had a chance to actually take a turn. And I caught a lot of hell for that, I'm not gonna lie. It was not a positive experience for me. Even when you're good at math, quote unquote, it can be a negative experience. Maybe not the same level, but it sucks that math is seen as a shameful thing, regardless of whether you're good or struggling with it. So when it comes to basic multiplication, I don't have a ton of great advice. I learned by rote memorization. I know that 4 times 4 is 16 just off of the top of my head. It just pops out. But I hope you saw all those visuals that we saw, and have students who are struggling, don't just drop them in front of a times table and say, here, memorize this. That's not the way we do things anymore. Instead, try to find places where multiplication is relevant in a way that makes it interesting. It's all over the place. Multiplication is everywhere. You should be able to find it. Again, board games, tabletop role-playing games, that sort of thing. If you must sit them down to take these exact tests, then try to make a game out of that too. Like I'm doing with my sort of achievement run to 100%, maybe that'll help. But again, and I cannot stress this enough, I am an education specialist mostly for secondary school. So my purpose here is mostly to have you my purpose here is mostly for people who are tutoring or teaching or mentoring young children, not the young children themselves. That's kind of my point. Okay, and again, the nice thing about these visuals is you could always just count them up if you needed to, or you could say there's 4 rows of 10, which would be 10, 20, 30, 40, or you could count by 4s, 4, 8, 12, 16, 20. I wouldn't do that really, but either way, you get 4 times 10 equals 40. And again, we're really solidifying the idea that multiplication is the same thing as area. If you look at those penguins and you kind of blur your eyes, that's a rectangle of penguins. And we found the area, how many unit penguins there are, by multiplying how many rows there were times how many columns there were. How many ranks, how many files. 2 times 7 is still 14. Again, let's do that a different way though. Let's see. 2, 4, 6, 8, 10, 12, 14. Yeah? That's another way you could do it. You could count by 2s 7 times. 1 times 8, well, anything times 1 is itself. We're multiplying 3 times 2. I love it. We've got 3 tables with 2 burgers on each table. I love this visual. And again, I hope that you are taking ideas to apply to real life, not necessarily to directly use these images. These images are just an example of things you could do. That's 6 still. Anything times 0 is 0. 0 is kind of the great equalizer that way.